I'm really happy with how it turned out personally. So, without further ado, I guess we can get into
the first week of school. We have like freshman orientation for the robotics class, and so we actually couldn't do anything that week. We couldn't build, we couldn't do nothing. So a lot of these guys were already a week ahead of us. So then we took that next week and we just planned out what we were going to do, how we what we thought in our head a robot should look like and what it was going to end up looking like. And we ended up using a bunch of Fusion 360, Blender. These photos were all taken from Blender about what our robot should look like, and those were also some of the stuff we did over the summer. And so then after we got all of that situated, that week done, then we just hit the ground running with an idea, which that base on there is exactly the same as the one on here. So it's almost
roughly the same.
Roughly the same. There's, obviously
we have another model that is exactly the same. Some of you guys have seen these pictures already. I think it starts there where you guys haven't, right?
And then we built the base. Obviously, when you start, you just go from the bottom up, and we ended up having a working robot for the first competition, which was really nice because there was only 16 teams at the first competition in the whole state of Idaho that were competing, and some of them weren't even from Idaho at that tournament, which was kind of nice to say that we were one of the first ones to be able to compete. And we also won that tournament, which was really nice. And we got the design award that tournament. So then after that tournament, we have this idea in our head that we're not going to completely rebuild our robot, because we've seen and we have completely rebuilt robots in between competitions, and it just does not work out from past experience and stuff. So we ended up fixing a couple things after that one.
So after that first competition, one of the things we changed is our mobile go lift. It used to be a rack and pinion set that actually just lifted the mobile go up. It didn't eject it out like this one. So we weren't actually able to score into the 20. We also had 6 wheels, as you can see in that photo, but only the back wheels and the middle wheels were powered. The front ones only coast, so it didn't allow us to get over the 10-point goal. So we also changed the drivetrain to allow so we could get over the 10-point goal to score into the 20.
After the competition, we all got together and we thought, what is the biggest thing that we can change to make our robot better? And we came up with the chain bar. It was a long chain bar. It was mounted back. These top bars were actually shorter, which meant the reverse forward bar didn't actually go up straight. It kind of went like that. So we couldn't put a physical stop on it. It had a soft stop by using a potentiometer, but it wasn't very effective and had a really high cycle time. It took a long time to pick something up and put it on, and it dropped it half of the time too. So we shortened our chain bar, and it worked a lot better to start, but we still had issues.
So we have this LCD screen which displays our battery voltages, which is nice, but we ended up checking them before we put them in anyway. But if we click any of these buttons, it brings us up to a menu. And then within the menu, we have a 10-point auton, a 20-point, a standard auton, which we've actually changed, we just haven't renamed it, and then a skills auton. And then so if we pick the 20-point auton, now we can choose between left and right.
A couple things that I thought of. We have potentiometers on the list, which allow us to, in driver control, button combination has a fully autonomous 12 staff.
Thank you very much.
Thank you guys.
All right. Well, thank you.
Good job.
Well done.
Thanks, guys. Thanks, brother. You guys are
Really
good.
short.